everyone. I am Tanya Jankin. I'm the head of community and education at Semgrep, and I am here with my amazing colleague Brandon. And we are going to talk about writing Semgrep rules today. And Brandon, welcome. Can you introduce yourself and just tell everyone who you are?
I very much can. Thank you, Tanya. I'm Brandon. I work at Semgrep, and I'm a program analysis engineer. I work on program analysis related things, static analysis. That's kind of my jam. So I'm really excited to be here. I really am excited about Semgrep rules.
Me too. And so a thing he didn't say is that he's also a really great teacher. And he taught this awesome workshop in Vancouver at B-Sides when we were both there. And I was in his class, and it was actually really fun. And maybe there is a video.
I think there's a video. So if we want to just go ahead and get started, let me share my screen here. So let me tell you, this is going to be the most important video out of this entire webinar. So take notes. All right. He fell. What happened? What happened? Oh my God. He lived. Don't worry about it. It's fine. But that video, that's not, he lived. It's okay. That video demonstrates the importance of what? What didn't he have? Guardrails. That man did not have secure guardrails. Tanya, you know the term secure guardrails, right? Could you talk to us about that? What is that?
So a thing Semgrep's been talking about a lot, which you might have noticed, is the idea that what if we put up, just like on a road, a technical guardrail, something that kind of stops a developer from making a potentially dangerous mistake. It kind of nudges them back on the safe path. And so an example could be like when you go to check in your code, there's a pre-commit hook and it scans it for secrets. And it's like, hey, there's a password in there. That seems like a mistake.
Yeah.
And then ideally you're like, oh my gosh, that was a mistake, and you don't do the bad thing.
And that's all we're looking to do, is to make the bad things happen less, right? And I'm a developer, so I totally get that. And in my CI workflow, if something is bugging me about some security vulnerability, that's great. Even better is if I don't even get to that point. So like, as you said, like having stuff like the IDE before I even commit my code, telling me, hey, like maybe don't, run input and then put that directly into eval. Maybe that's a bad idea. That's such a cool thing to be able to do. So I'm very much a fan of the secure guardrails thing, and so is Semgrep. And so the thing we're talking about today with Semgrep rules, Semgrep rules are how we kind of are able to enforce those secure guardrails. And so one thing I wanted to talk about also before we get started here is like this Semgrep rules thing. The customizability aspect of it, I think, is something that's so cool because, what would you say? How do you feel about let's talk about this. What if we had one size fits all clothing? Should we all be wearing the same size T-shirt, Tanya? Is that something that we should all be doing?
I don't think we should do that. I don't
think my T-shirts are the same as yours, right? I think we have different sizes and different needs, and that's not something that works. So why should we have these like secure guardrails or these practices that are uniform amongst every repo, every team, every company that is maybe working within a single language? So that's another thing that I was thinking about with respect to secure guardrails, where with Semgrep rules, I'm so excited about the fact that we can customize them because, so maybe to give a bit more context here, is that Semgrep finds what you want it to find, and the things that you want to find are codified in YAML rules, right? And so you can write different YAML rules based on your needs. Maybe you say, oh, I have this sensitive function, but actually within our code base, we have a different function that sanitizes the output of that or makes it safe. But with a Semgrep rule, you can easily customize it to those needs. That's pretty cool, I think. So I'm just overall super, super excited about using it for this customizability aspect. Yeah. Tanya, what are you excited to talk about today?
Well, I'm excited that people showed up. Hi to the people who showed up. Welcome. So hi to you people. You can ask questions in the chat. I just put hi everyone, so that you know where the chat is. But yeah, it's on the far right at the bottom. Hi Juan.
Hello.
So if you want to ask questions at any point, or if you want to like write the rules with us, and then you're like, oh, I'm stuck, something's wrong with my syntax, or I have the red squigglies of death on my YAML, which is rather common, then just put it in the chat and we'll be right there. Because like, yeah, this is interactive and we want to talk to you too. So I'm excited that people showed up. This is great because this is our second show ever. And you don't know when you start doing something if people are going to come. So thank you very much for coming.
Yeah, thanks so much. Cool. Yeah, but so excited to get to things, and so excited that everyone here showed up. So we're gonna have a good time talking about some security guardrails. One thing I wanted to talk about also that I think was really really fun was our CEO Isaac. He has this article he wrote on our website, and one quote I found that was so choice was he was talking to this security engineer at some big financial institution, and they told him this quote, which was, he gloomily remarked that given the chance to go ahead and fix all of the bugs that were in the backlog, it would take them 100 years to get through their vulnerability backlog at their current rate. And I think that that's so profound in a way that's like we can't just like be chasing after doing firefighting, where we have to proactively be able to put up barriers that will help keep us safe and keep the bad things out.
I just put a link to it in the chat.
Oh yes. Oh, you found it. Nice. Yeah. So if you find this is you're interested in this, that's one of the a good blog post I read that kind of describes the thing that we're kind of talking about here. Yeah. Shift left. Cool. Okay. So should we just go ahead and get into the rule writing then?
Yeah, let's do it.
Let's do it.
I feel like people that are coming will be here now.
Right. Okay. And feel free to chime in at any point if you see something interesting. But basically, boom! I got colors and everything. We're reusing some slides I made a bit ago just because they have some nice graphics. But we'll be here and answering any questions. Please chime in at any point if you have questions about anything. Make it cheap to make it expensive to write secure software, or prevent people from shooting themselves in the foot. I like the latter one because I'm pretty good at not doing that. But we have to be better about doing the first one too. All right. So basically, I'm going to skip over all this. I don't know how much people here know about Semgrep, but Semgrep is cool, and there's a couple reasons why it's cool. One reason that's cool is I think is that it's open source. So you can go find the code that I write every single day on GitHub, github.com/semrep/semrep. Actually, maybe don't do that, but it's customizable. We talked about, but also we don't have to build code in order to scan it. So Semrep is a code scanning tool. We can read your Ruby code, your Go code, your Java code, your Scala code, your Haskell code, whatever, and then tell you, well, not Haskell, and tell you what's wrong with it. But we don't have to be knowing anything about your build system. I don't care if you're using GCC. I don't care if you're using Clang. Either way, I'm able to read your code and tell you what is wrong with it, hopefully. And then this thing about Semrep patterns looking like code is that there's no DSL. So Tanya, you know about CodeQL, of course.
I do, but I haven't really used it.
True.
But I've read a book called Black Hat CodeQL, and I was like, oh my, there's a lot of dangerous potential within it that I didn't know about before reading the book.
Oh, really? I see. Okay. I didn't know there was a book about that. Yeah. So
one of our customers wrote it.
Oh, cool. Okay, cool. Yeah. So one thing about CodeQL, and this is like not specific to them necessarily, but sometimes you have to learn like kind of a different language in order to run a security tool. There's like particular libraries and a particular syntax. Semgrep is just YAML, and everyone knows YAML, so that helps to some extent. Here's some ways that you can get Semgrep. So you could, for instance, go to well, I'm not showing my whole screen, but if you wanted to, and people, followers along at home, you could do this if you wanted. You could literally brew install Semgrep and have Semgrep in like 15 seconds. That's it. You can have it for free, and just by doing that. And that will install the Semgrep command line utility to your computer, and then you can start scanning in another 15 seconds. We also have VS Code extension, which kind of lets you do the thing that Tanya and I were talking about, which is being able to scan code from your IDE before you commit it. And then, of course, we have our open source repository, which I talked about. And I'll skip over these two for now. Cool. So let me get let's see. I don't know how the whether there's a show of hands feature in this call or something, but are people here familiar with abstract syntax trees, or ASTs? Which is kind of like not critical, but is nice in order to understand. Yeah, so you're familiar with the fact that, so for instance, we have a program here in Python, and we can parse it to what's called an abstract syntax tree, which is just like a tree that represents the hierarchy of the program. And then from there, what Semgrep does is it goes and does things like constant propagation, taint analysis, and pattern matching, which is how we go and find bad things that may happen in your code. So for instance, suppose we had this program that we had on the left page, and if you don't read everything that's listed here, don't worry about it. I'm kind of just like verbally saying the important parts. But we may say that, like, for instance, this program on the left here is actually is two statements. One of them is this b equals 1 assignment, and one of them is this red node, this def foo, right? And we can represent that as a tree where it has two children, where one of them is this b equals 1, and one of them is this def foo. That is going to be our tree, and that is basically how we would represent this program. But we would say that these nodes of this tree, this yellow guy, corresponds to the range, that is to say, like, characters 1, 2, 3, 4, 5. That is the range, the textual range, like the pointers that denote the start and the end of that node. So that means that if we wanted to, for instance, I'm going to use the term I haven't defined yet here, match b equals 1, we would get this as highlighting. But if we wanted to, for instance, match this def foo red node, this red range would highlight instead, because that covers the whole range of the node. I think it makes kind of like visual sense. I think it's like a thing you can kind of see with your eyes and kind of get an intuition for, right?
Yeah.
Yeah. Okay. Cool. So we can also break this down even further, though, because it doesn't stop there. We keep going down, because even within our assignment, the b equals 1 that we identified before, which represents this whole thing, we have that this is made of a b and a 1, which cover the green and the blue range, respectively. And also in the def foo function, which is this red thing right here, it's made up of a few other things, which is this foo, this a, and this a plus b, which we could further break down into an a and a b. If you wanted to keep going. But basically, I'm saying that, like, this structure is highly nested, and you kind of get this like tree thing out of it. And we like trees a lot. All right, we're big fans of the planet. We're eco-friendly, so trees are like kind of where we're at, right? We want to have plenty of trees. I saw lots of trees when I was in Canada, so we can go ahead and keep going with this. All right, so basically, this is the same thing I just showed you, but showing how we can break down the trees into smaller or bigger trees, maybe. Okay, let me give you a very concrete example, right? So, like, let's suppose that we were interested in finding calls to the function print. Like, I started my new job, at a small software company named after a fruit that grows on apple trees. Okay, and they don't like the function print because they want me to use like logger.input. We've all been there, right? There's like a special bespoke kind of like printing function that you don't want to use. So we want to flag with Semgrep every usage of print. So obviously we want to find this first one. We want to find the second one, but we don't want to find this, third one. We don't want to find the second one, right? Because that's not the print function, right? That's is printed. Tanya, that doesn't seem right?
Because it's a good one.
We only want to
find bad ones.
It's a good one. Yeah, that's true. You have to get yourself in the mindset of only wanting to find the bad ones. So yeah, is printed is good, so we don't want it. Nice call out.
I had a lot of problems with that when I started writing rules. I kept trying to find good things, and they're like, that's not going to help you. There's going to be way more good code than bad code, Tanya.
Right. I think that's the optimism out of your perspective there, which I admire. That's good. That's a good thing. We shouldn't find it. Cool. So I actually already spoiled this, but Tanya, could you tell me if I wanted to like grep or control F for print, what would happen?
You would find both, because the word print is in both. So we have to figure out how to tell it, I just want to find print, not with anything in front of it or behind it.
That's crazy. Yeah, we'd find all these prints. Tanya, that's a lot of red, isn't it? Holy moly. I got to like sort through all of these. And if I'm a security engineer, that sorting through it is not just me looking at it, and glancing it over in like 5 seconds like I just did with this. That's me spending real time that I don't have to go and sort through false positives is what we call it, right? And generally speaking, false positive, that is code, and it's code for bad. Bad. So we don't like that. So what we're going to do is
Can we define false positive just in case someone is quite beginner?
Absolutely.
It means your thing is reporting something, but it's not actually what you're looking for. So you're getting a false result, and a false negative is where you run your test and you don't find something you were supposed to find. And both are bad, but we're going to talk a lot about false positives today.
Yeah. In static analysis, false positives, false negatives, like that's our main thing that we're thinking about all the time. And you really want to minimize the false gives it away. You want to minimize both of those for sure. Yep, absolutely. Cool. So Semgrep stands for semantic grep, but basically the idea is that it's going to be, yeah, that's true, Juan. You definitely could do that. But yeah, the ergonomics are going to be a little bit better. But good call out. Yep. So Semgrep is going to be able to search our code in a way that lets us do this. And here's the main idea. In Semgrep, we have these things called patterns, and we have these things called targets. And actually, I'm just going to go over to the playground and show you. If you want to follow along, let me give you a link right now. You can go to semgrep/playground/new. But what I'm going to do is I'm going to start sharing that. Let's see. Oh, is it this one? You can see my Semgrep Playground link now, right?
Oh, I was on mute. Yeah. Oh,
okay, cool.
Yes, I see it.
Yeah. So here is Semgrep Playground, and all you need to know is that we have a pattern on the left and a target on the right. So this is your real code that you would be scanning, and here's the query that we want to put into our engine in order to scan it. Okay. Now let me. The start example is a little bit different, but I'm gonna write this: print dot 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 left print left paren dot 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 right paren, and this is in Python. Now you might be thinking, Brandon, I don't know that that's real code, and actually I don't think it is either. But that Semgrep patterns look like slightly augmented code. So basically, to search Python code, I'm going to write a Python program, subprogram, but add a few things in, like dot dot dots, which means basically a 0 or 1 or 0 or more things. So if I run this rule, I'm going to go hit this run button. What's going to happen is that we're going to go and flag some stuff on the right here. So remember that things I was saying about the AST nodes. If we think about the nodes in here that correspond to this print, the parts of the program that are prints are these guys. Any calls to print are the ones I found here. But note that we didn't get this one, which is commented out, right? And also if I put is printed true here, like we had in our previous example, I would also not find that. Pretty cool, right? And the reason that this works is that we're not matching based on the literal text. I'm not looking for literally a print, a left paren, and then any number of characters. I'm looking for actual nodes in the abstract syntax tree of this program that correspond to this print. Yeah. Tanya, does that make sense?
It does make sense. I feel like, yeah, this is good. It's good.
Oh, yeah. All right, let's go. There's a few other cool things that we can do here, but basically the basic idea to have here is just that we're using AST nodes to match to each other. Cool. So let me actually try out an example here with you that I have written up from somewhere else, but we're going to try and find calls to functions that we think might be dangerous to use, functions that we want to outlaw within our particular repo or our particular organization. And let me try to get that for you here. I have the link on the clipboard on Slack, but I have to open that up first. If I had the ability to start playing the do that song, I would.
I wish that clipboards could have like 20 things on them, but then it would be like tabs for me, and I'd have like 500 things.
I would just forget so easily. Yeah, no, for sure. So, what we don't like a lot is we don't like exec, right? Are you a big fan of exec, Tanya?
We do not want to use anything that will run commands against our operating system. We don't want to do that unless we're being extraordinarily careful.
Right. So when I bring in my junior dev intern and they use the exec function, probably my eyebrows are going to be raised whenever I see them do that, right? And so the question is, like, if you're going to be doing this code review and like try to catch these like potential security vulnerabilities, why not have a thing do it for you? So Semgrep will be that thing. Spoiler. So we're going to try and make sure that we don't have any calls to exec. So notice that we have a call to exec, we have another call to exec, and we have a call to definitely safe function. Tanya, does this look like a definitely safe function?
If we're just putting user input into it and it says import exec as, like, it's a a bit of a trick. So whenever I see devs do stuff like that, I'm like, why are you just messing with my brain? Like, why would you? I know it's possible, but why would you do that? Why are you making everything hard? But I've seen devs do stuff like this, and I'm like, please don't. Simple's better.
Right, exactly. So let's try to downscale from it and not, maybe don't import the unsafe functions as definitely safe function. So if I wanted to find all calls to exec, I could say I want to find exec, right? But then the question is like, this is not a call to a function named exec, right? Oh, darn, bummer. Looks like we're not going to be able to find it. Oh, just kidding. It didn't load yet, but just kidding. Semgrep is smart. So Semgrep is going to know that exec was actually aliased as definitely safe function. And so when we say that we want to find all calls to exec, it's like, I got you. This is also a call to exec, which I think makes sense, right? It's just what the program is doing. So this is what we mean when we say that a semrep is semantic. It's aware of what you're doing in your program. And this is like not something that you would want to do with like regex or grep or something, right? We could have like a billion and one things in between these, right? So awareness of the control flow actually helps us out a lot here, I think. Cool. Yeah, are there any questions, by the way, before we proceed with other things? And I realize this is going to do this every time I do that. Let me disable for now. Just want to make sure that everyone is on the same page.
Yeah, I agree. That's a good idea. One, being ahead of yourself's okay.
Okay, that's fine. I mean, we can go to whatever. This is also like, we're here for your questions and also your examples. So if you wanted to go through an example specifically, we could also do that. Can you both apply, fix, and flag and match? That's such a great question. All right, let's get into it. Yes, the answer shortly is yes, you can. Yes, you, or recently we have this thing we like to say at Semrep. Yes, we scan. That's a fun one. So here's what you can do. Let's say, let's not do this example. Let's do the print example. So we have the print example where we have print and we want to replace it with a call to, let's say, logger.info. Okay. Let me simplify a bit. You can do it for the other ones, but it'll make the rule a little bit more complicated. I don't want to inundate you. But let's suppose we have just these print examples where they take in a single example. We're going to use what's called a meta variable. So instead of this ... which says match whatever, we're going to do this, $x. Now, $x looks new to you probably. It's a special semrep syntax, but it says that when I have a print call, I want there to be only one argument, and I'm going to bind it to a meta variable called $x. I'm going to assign it to $x. So $x now is whatever is inside of that print. And then down here, I can say add fix, and then say logger.info $x. So I'm reusing that $x and saying that whatever my print contains, all this rule is saying is whatever my print contains, replace that print with logger.info of that same thing. So if we run it here, we're going to get two matches, and we're going to see here that I have two what's called autofixes. This thing we just did, it's called an autofix. And I can hit this hammer right here onto the program and then say replace this print with logger.info, accept it, and I can rerun it and do the same thing. And then I can also replace this one.
So easy. What if we wanted to do multiple arguments?
Right, so if we want to do multiple arguments, what we would do is we would start using this thing called an ellipsis meta variable. It's a little bit more complicated, but not a lot. Basically, you see how, you see how I did $x? I want you to think of that as a special meta variable that, because it has this ... it has a special property that it's allowed to like be multiple things. Okay, when your parents when they tell you can be anything, you can be multiple things. That's this basically. So $x can take the place of 1, 2, 0 arguments. So if I print, let's say A, B, I'm going to run this again. Oh, sorry, I need to make this also $. So if I did this, what we'd experience is that we get these two autofixes as we expected, right? That's the same as we had before. But we'd also have logger.info A, B. The reason we have this ellipsis meta variable is so you can kind of distinguish having like one thing or two things versus having like any number of things, okay? $x is very powerful. It can be any number of things. So including 0. Yeah. So does that make sense, Juan? Like this is the kind of thing that we can kind of do. Oh, sorry, you had a question actually about the $X. Yeah, $X cannot. Cool, awesome. Yeah, good question. This is definitely something I'm very excited about in terms of Semgrep. We've used this internally for mass code refactoring because that's what Semgrep is kind of very, very good at. You have a particular undesirable pattern in your code, and you just go and you fix it at scale, and you don't have to have human error at every single site where you're like, oh man, looks like I missed a left paren. Oh, well, sorry, looks like you're going to be crashing in prod 20 hours later, right? Yeah, you looked like you had a particular reaction to that. Yeah, but
I have crashed prod before, not very many times, but
understandable. Yeah. I have too, so I get that. But instead of we having these fixes and having these security guardrails, we can be well off. Okay, so let's move on to the next thing. So we talked about auto fixes and we talked about these rules, but one thing that we can do is we can make these rules bigger. And making them bigger is sometimes correlated with better, and I would say actually often correlated with better. So in this view, and by the way, there are two different views for rules, okay? We can have this structure mode that's called, which I like because it's nice UI and I'm kind of silly and I prefer it, but you could also go back to YAML. So I kind of mentioned earlier that Semgrep rules are written in YAML, so we can have this, and then we can, if we wanted to, we would be instead of doing this thing, right? We'd say $X here, or ... and this fixed field is where I put the autofix, or we can look at it in a UI. I'm going to do it here because this reduces our capabilities for errors. When Tanya was talking earlier about there being like red squigglies for unknown reasons, that is a thing that can happen in YAML quite frequently if you do something silly like indent the wrong way. So let's not focus on the indentation too much for now because it's kind of annoying and I don't really like that it exists.
And structure mode's cool.
What was that? Oh, structure mode's cool. Oh, thank you.
Yeah, it's cool.
Yeah, I think so too. I implemented it.
Did you work on it?
Yeah, this is entirely my project actually. But yeah, I think it's pretty cool. But let's proceed on with this. So if I click this little drop down here, I'm gonna get a few things. I'm gonna get pattern, any, all, regex, and these two things here called inside and not, which I'm not going to talk about just yet. But right now, these are the main ones that are important. Okay, so we have any and all. Tanya, any and all. What does that make you think of? What does that rile in your brain?
So if it has any of those, it's cool. But so it's like or versus and.
Yeah, exactly. You're exactly correct. Or versus and, which is like basically like there existing a thing versus there being all of the things doing a thing. Yeah.
Yeah, like if there's 5 things, it's like if you have any one of these things, then it's a match, and all means you have to have all 5.
Exactly. Yep. And so you might think that actually we'll be able to have indeed like a lot of things here. So what this lets me do, if I have any right here, any says match when any children patterns match. So for instance, let's suppose that I'm not interested in this print with empty, right? Like I'm actually really let's suppose I'm only interested in this print that has no arguments, right? Or I'm not interested in that here, sorry. I'm interested when we have 2 arguments, when we have 1 argument, but not when we have 0. So what I can't do is I can't write $.x, right? Because as we saw, it captures everything. What I want to do is instead I'll do a pattern any, where I'll do one of them is $X. Another one of them is $X comma $Y. And this should again look like Python code where instead of having an expression here, I have a meta variable, and instead of having an expression here, I have a meta variable. And if I run this rule,
you'll
get yes, I will get both.
What if there's a print argument that has 5 or 7? What do we do?
5 or 7. If we had 5 or 7 arguments, well, we could then, depends on if we only care about the 5 or 7 arguments. Here's kind of where we get into this false positive, false negative thing. Because like if we had 5 or 7 and there were a lot of them, sure, maybe at the end of the day, A, B, C, D, E, F, 1, 2, 3, 4, 5, 6, 7. Maybe we wanted to do that, and then we'd still catch this print, left paren, right paren, or maybe we really care about the number, and there's not too many of them, so it's not bad, and we'll go and we'll enumerate the number of arguments that we have there, and just put in a standalone meta variable for each of them. Generally, I find that like you usually fall into the camp of 1 argument, 2 argument, 3 arguments, and there aren't too many. But it's really a matter of like writing out what you care about. But yeah, good call away. Cool.
Can we say don't find a print statement that's empty?
Can't we say don't find a print statement that's empty? That's also so Tanya got ahead of me actually. That was a good call out. That's the other way of thinking, which is like kind of negative thinking. So let's suppose we cared about 1, 2, 3, 4, 5 arguments. Oh my god, so many, but we didn't care about none. In which case, like we want to write this and be done with it, but like this is kind of silly. We don't want to deal with this. So what we saw earlier is we had this like not thing, right, which we couldn't select. Well, we can't select it here either, but what we're going to say is we don't want to match one of 2 things. We want to match when 2 conditions are true, when all children patterns match. So let's do an all, Tanya, as you identified, and we're going to have this guy be a not. So we're going to say we want to match any call to print with any number of arguments, that's this $x, but not this guy, the empty print. And if we go and we run this, what we're going to find is we don't find it. There we go. We got rid of our false positives. Yep. We got rid of our false positives. Now we don't have the print with no arguments. And I understand that like this example here can seem like a little bit contrived. We're kind of just doing it. It's kind of like, a play example for us. But there are a lot of very real use cases that essentially look very much like this. Like we'll swap around the function name. We'll add like dot or something. We'll say a dot b or whatever. But they are very, very similar to this at the end of the day. So very, very important for us to get to. So, and we'll look at a few more examples later that I think are a bit more representative. Yeah. I see somebody typing something, so perhaps we have a question. True. You cannot only have a not match. So I want you to think about it like this. When I have a not, I'm taking stuff that exists and I'm filtering it out. If I have just a not, what are my inputs? What am I filtering on? A not removes stuff. But in order to remove stuff, I have to specify what I want in the first place. I can't tell you, I want to take away 5 things, unless I tell you what I want to take 5 away from, right? So that's the difference there, is that I really need to be able to, what's called a positive pattern, this guy right here. In order to have a negative pattern, I have to have at least one positive pattern. Does that make sense? Kind of think of it as like, I have to be, if I tell you to take away 5, okay, maybe let's try it along a different tack. So,
well, imagine an expression that was just like -5. It's like that's a value. It's not an expression anymore.
Right.
But if you have 6 minus 5, you have an expression.
You have an expression versus -5. Let's think about, not minus is like a unary thing. Minus is like a binary thing, right? It's missing an argument. In order to subtract, I have to tell you what to subtract from. So think about like this take away 5 thing. If I go up to like a kindergartner and I tell them, I want you to take away 5 buttons. They're wearing like pants. They're wearing like a jacket. They tell me to take away 5 buttons from what? They can assume, but I don't want to assume. I don't want to assume what you're saying. When I tell you, not print, I'm wondering what your domain, your positive things you want to find are in the first place. What is the thing that you want to find that you want me to take away prints from?
Ambiguity.
That's kind of the difference.
Ambiguity is the most terrible thing when it comes to computers, because then the computer is going to make up its mind, and it doesn't always make up its mind the way we want it to.
Yeah. That's another way to view it, is like it's a kind of a design decision where if we allowed you to do that, we would have to start making guesses about what you wanted. As like implementers of the software, we'd have to make guesses about what you want, and that is dangerous because then somebody's going to be there that who their inclination, their intuition is different than what we thought they wanted. So very, very clear. You can't have a not unless it's accompanied by the thing you want to take a bite out of, the thing you want to subtract stuff from, because otherwise we have to guess what that is. And then that'll get you into kind of all sorts of potential dangerous areas. Yeah.
It's such a good question, though, because to be quite blunt, I was like, I'll just use the not statement when I had my first lesson on rules. And so it was my thing, too.
Yeah.
Um,
So that use case is actually an interesting one because it kind of straddles the line. So we have making sure
read
that
it out loud,
indentation.
Brandon, for
Yeah,
people later, please.
right. So making sure that indentation was made with multiples of 4 spaces. Now, it may be the case you could do it with SemRep. I think it'll be a little hard because one thing about SemRep is that it tries to take away you having to think about the very concrete syntax of things. Like we're dealing with more abstract stuff. Um, I think you might be able to, but it would be difficult for sure. Because
Aren't there,
you'd have to use. Yeah, sorry, go ahead.
aren't there tools built for that though? To
Right,
format your
there are
code?
tools built for that. Yeah, formatters are generally things that. So SemRep is in a place where we're trying to find things for you. Reformatting your code is a different use case. Generally, we'll leave that to an auto formatter for you. You know, your roughs or your black or your what have you, ESLint. We're not really a linter. We can be a linter, but we don't cover all of the use cases there in terms of formatting your code. So making sure that indentation is correct, you probably could, but you would have to probably do some regex stuff. I don't know how you'd manage the regex. No. Yeah, for sure. But it would be kind of an interesting use case. Yeah, I mean, you kind of intercepted me there. Like, I'll definitely take a look at that after this. But yeah, the arithmetic part of it is something interesting. But yeah, for now we're gonna try to focus more on the security vulnerabilities, but definitely like finding stuff that's like just code smells and stuff is a valid use case. Yeah, so the way I would think about it actually is no, because I was going to say that you could try to capture the whole line and then assert that the regex was like a certain length, but capturing the line is actually probably not going to capture the white space in front of it. I'll play around with this afterwards, but you know, this is very easy to get me thinking about one of these problems. It's like I want nothing more than just like tackle it because like writing Semper Rules is a lot like just like solving a little riddle. It's like a little puzzle, so it's kind of fun to do. Oh, nice. Okay, yeah. Like, using a regex kind of match would work. Yeah, for sure. Cool.
I feel like when you have the wrong tool for the thing you're trying to do, you have to work way harder. Like on the weekend, so I'm building a fence with my significant other, and we had to like dig all these holes, and there's all these roots or whatever. Anyway, so I have this thing that chops, and it got stuck on a root, and I couldn't figure out where we put the hammer because our fence is like 400 feet long, and it was somewhere along the fence. So then I was like trying to, without a hammer, get the thing with the wrong tool. It took like 5 times as long. And so, yeah, Semgrep can do a lot of things, but it's not a hammer. So, yeah, I feel for you,
Yeah.
man. Being
Yep.
told
All
you got
right.
to use this when you're like, that's not what that tool's for.
Nice. Yeah.
Oh, grep nice.
Grep Yep. Cool. Okay. Yeah, that makes sense. Yeah, I will say that SemRep is generally like a Swiss Army knife when it comes to static analysis because I don't think I touched on this super much, but it's a kind of the polyglot static analysis tool because we can scan a lot of languages. I think 28, 30 plus at this point. And the reason for that is that we use our own special internal representation for every programming language. Every programming language gets treated the same, and it means that we miss some nuances, but it means that by and large, we get to analyze them all the same and get very far with that because it's a force multiplier. So it's pretty cool, I think, at the end of the day. But generally, it is pretty able to do a lot of things within one package. Cool. Okay.
Juan, we're
Um,
biased, but you should pick us.
no way. Really, Tanya? That's crazy. Holy moly. I
Who
should.
would
That's
have
good.
thought we like it? Surprise!
Nice. Cool. Okay. Um, ugh. Sorry, I'm a little. Ugh. My voice is a little shot this morning, but we're gonna proceed ahead and keep going on. So we looked at all and pattern and any and not. There's a few other things that we could do. Like Juan was kind of talking about, we could use regex patterns. So for instance, I can write a regex. And what I'm gonna write is I'm gonna write like print, and if I run this is just gonna search all of the text and find me, like we said earlier with grep, you could just go ahead and search for a regular expression and then find all the instances of print. Now, obviously, this is like not super desirable because we find all of these things for our use case, but there are use cases where sometimes using the patterns to match things doesn't quite get you as far as you need. Kind of like we were talking about actually with this indentation thing. what you could do
Spaces.
is you could find what is it, like \w \w
Mhm.
uh
Or carriage
oh,
returns or whatever.
yeah, wait, I'm losing my. Did I
Stuff
switch to
that
terminal
isn't
mode?
code, but that's totally in your program.
Right. Oh, here we go. Here's my phone.
One
I'm not
sent
like
the
I'm.
regex for you. That's awesome.
Yeah. So like, actually, now I'm just curious. Now I'm just curious. And this is 1, 2, 3, 4. So it should work. Well, I'm not an expert at regexes. So maybe I have to escape one more time. I think it would also work if we just did that. Well, whatever the white space regex is. I always have to look these things up whenever I'm writing regexes. I make constant use of this tool called regexer, which will write me the word. No, that's my thing. Is like it's not clear with regexes because \w makes me think \white space, but it's actually not the case. Okay, yeah, okay, I see my mistake. Yeah, so like that's also another plus about using, I think, regex or sorry, semrep, is that like these patterns we're writing, they kind of read like human language, as opposed to when we're using a regex and then you miss a single, \s, and then you. I mean, I've seen some truly horrid regexes in my time because that's a big part of like secret scanning. I like that.
The plural of regex is regrets.
I believe that. Yep. Yeah,
I
110%.
totally.
110%.
I have a
I somebody who's
meme
been there.
for. I have a meme
That's a
for
good
our
one.
newsletter this month, and it's like, regex, why can't you just be regular? And then like there's like a lizard, and it's like and then it's like this crazy regex thing.
Yep.
It's like
Yep.
there's nothing
I've seen that
regular
one.
about regular expressions.
Yeah. If only. If only. Yeah. That's so funny though. You should put that somewhere. You should put that. That's a
Oh,
good one. All
oh,
right.
that's going in the newsletter one. You win.
There you go. There you go.
You
We can have
win this
a joke
stream.
of the week. We can put that up. Yeah. That's the community right there. That's okay. I mean, this is the first I heard of it, so
I
somehow.
love it.
Good one though. Yeah, it does. Internet has it all. Cool. Okay. Let me try to think about what I want to talk about next because here's one we can do. So let's say that we're working in a and I'm skipping a few actually, you know what? Let's do this example because I kind of think that it's kind of nice. I'm trying to give you some examples that feel representative. Oh, sorry, this is actually the same one. Secure named arguments. Yeah. You'll excuse me the pause briefly because I'm going to copy and paste things on my clipboard. Okay. Basically, what we're trying to do, and here's, by the way, I didn't explain this, but maybe you get the point, is that when there's a hashtag rule ID, when there's a comment with rule ID, it means that the next line is bad. It means that we want to have a match on it. When we have a hashtag okay, there's a comment with okay in it. It means that the next line is good. It means that we don't want to find it. Okay. In this case, what is bad is that we're doing requests.get, which you may be familiar with. But we have this thing where you have the potential to set verify to false. Now, I don't know about you, Tanya, but that sounds sus to me. I don't think you should want to set verify to false. I think that is dangerous behavior that a dev should not be doing, right?
Yeah, well, why? Why would we want that? Or why would we not? Why would a dev potentially do that? How about that?
Maybe it's because, well, I could think of maybe it's like slowing them down or it's giving them some kind of like error message because it's not verifying something and they're like, what the heck? I need this code to ship. So let me just, no one's going to check my code. No one's going to care that much, whatever. My manager's not going to care. Verify equals false. There we go. But, this means your code is more insecure. Something that bad could happen. And it'll be on you at the end of the day. So kind of like short term versus long term here. The dev might do this in the short term, and in the long term, you get pwned, and then you don't want that to happen. So if we wanted to make this not happen, what we would do is, let's say we would want to type in. So we're going to do something similar to before. So this is how we would write any call to request.get. This is a pattern for any call to request.get, but we want particularly to do only the one where we have a keyword argument verify set to false. So let's do that. What I'm going to do is I'm going to treat ... almost like it's its own argument. So I'm going to say dot, 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 comma, dot, 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 comma, dot, dot, dot. Now I don't need to do this entirely, but I'm just trying to get across to you. We can treat dot, dot, dot like it's its own argument, meaning that this is like any number, really. And this middle dot, 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 I'm going to actually replace with verify equals false.
Yeah.
Now to do this, the way you should kind of read this is I have dot, 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 kind of like the same way that you say dot, dot, dot in conversation. Oh, dot, 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 etc. Verify equals false, comma, etc. Da, 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 da. Same thing, same vibe, where I'm just saying any number of stuff can appear before the verify equals false. Any number of stuff can appear after. I don't care. I just care the verify equals false is in there somewhere. So if we run this,
you're saying it could be nothing before it and nothing after it as well.
Good call. No, absolutely. It could be nothing. It could be literally, I guess you wouldn't actually realistically use a library like this, but it could be this, right?
In case weirdness.
In case it was, if it was a library function that you could call like this. Indeed. Any number of stuff, including 0. So all we're doing is we're asserting that verify equals false has to be in there. So I'm showing you that like any like Python like kind of normal thing you can do, like this is actually like, you don't need to have me tell you to do this. If you waffled around with it and you kind of just like tried it, this would work. I think this is a pretty decent first cut guess at what you think it would be if you wanted to catch this in Python. So I think this is a pretty cool example to kind of show that off.
And then the severity we chose was error. So it's like, it's going to throw an error for us?
True. Good thing to call out. So we have these severities in our rules. Each rule is assigned a severity. What that basically means is that when you map this back to the semgrep CLI, it will decide on like what error that it reports for each of these findings. And you can use these to kind of tell what actions you should take on these findings. But it's a way of kind of categorizing how bad a given finding might be. Because some findings are like, they want you to know. Like, oh yeah, maybe don't do this, like, it's like a more of a code smell thing. Maybe you shouldn't use, print. Maybe you should use logger.info. I'm just letting you know. That's a warning. It's not going to crash your program. If you do something more heinous, though, you use executive input. Okay, like maybe that's like, maybe we should like stop the press. Maybe this is a bit more of a problem. All right. So we can kind of like in the rule, we can kind of bake in our idea of how bad is this finding really for easy sorting later, easy sorting and categorization.
Nice.
Okay. Cool. Okay. Let's look at a new example. Eventually.
While you're switching, I'm going to show you the flower that's on my desk. So I'm growing flowers this year, well, most years. And I've decided to just show flowers to people each day because I can just like cheer people up. Some people really like flowers. Not bad,
What kind of flower is that?
It's called a dahlia. And it's like, it's
dahlia.
about, I cut it 5 days ago. So it's like it's a little sad now, but not bad. Not bad.
Cool. Okay. Dahlia, right. It's like one of those names that comes from the flower. And I didn't even realize until like a long time later, I feel like. That's a nice flower, though. I like that. Oh, thank you.
Juan is saying, besides error, there should be an option to slap with a trout.
I don't think I got that reference, but I get where you're going for. I understand what you're saying in spirit. Honestly, yeah. Slap on the trout, slap with the trout, slap on the wrist, something. Oh, wow, reloaded.
I mean, a slap with any fish. It's so stinky.
Boot to the head. Boot to the head. Nice. Cool. If only we could do that, but until we get to the point where we can, enforce that across network connections, we'll have to stick with the errors. But one day. For now, you never know. You never know.
But what if Semgrep made a list for the AppSec person of people they had to go and just give the frowny face to?
I would be okay with that. I would be okay with that.
There's 3 devs this week where you have to go to their desk and just be like.
It's kind of like. Here's what I want to see. It's kind of like the Duolingo owl, where the Duolingo owl will just like complain at you if you don't do like your lessons and like set you in like a sus kind of way. Like I think that we should have like a Semgrep analog.
The mascot. Get a mascot. Yeah. When we have the mascot be like.
Yeah, well, we're working on a mascot. We're working on it, but maybe.
Or have the mascot be like, "Yeah, good choice," when it does a good job.
Maybe like complete a lesson on Semgrep Academy or something. That would be cool. I would like that. That would be fun. Maybe one day. We'll get
Sorry,
there.
we're so off topic. I'm sorry, Brandon, but I'm just like,
I mean, we have like, I'm not gonna lie, like we're partially because I think people here are kind of getting it, I think, but we're moving actually pretty fast, I think.
yes.
Like we still have a good hour left, more than an hour, so we got plenty of time. Okay, but in the meantime, we may as well talk about this one. So we have changed languages. All right, we have changed languages. This will happen occasionally, because SemRep is agnostic to languages, and so should security be. But right now we're working in Java. You can tell because you can see Java down here, and you can also tell because there's Java code on the right. So what we're doing is right now we're working in like a Play financial trading application, or something, where basically we have functions that take in a transaction. And basically all that we want to make sure is that before you call make transaction on that transaction, you have to verify it. Okay? If you don't do that, bad things are going to happen. Your head of finance is going to come and hit you with slap you with a trout. All right? So we want to make sure that does not happen. Okay? So let's try this out here. So in order to do this, we're going to start writing a pattern for just Java functions. Okay, let's start out with that. When I write a SemRep rule, I try to take it in an iterative way, where I kind of like try to match the more general thing and then specify it to what I want to do. So let's write a pattern that finds just the Java function. Does anyone want to even hypothesize what we could write to match like a Java function? If anyone has any kinds of guesses, what could we write to match any Java function at all? And let's say it's public actually. Let's say it's public. I think that'll make it a bit easier.
Any Java
Public function, let's say. Any type, any number of arguments, and any name also. Yeah, so let's try that. So ret, one says ret fun args. So if we try this out, we're actually going to be able to do a partial match onto just the function signature. And if we wanted to also have the function body, which we're going to need for a bit later, we would just do what you would think with Java, and we would put the curly braces and the dot, dot, dot. So exactly right, one. Nice job. Cool. We got it. I know also if we didn't care about the arguments, we could also still use a dot, dot, dot here. Dollar dot, dot, dot args isn't wrong. You're definitely still right with that. But if you wanted to make it a bit simpler and you didn't really care what dollar dot, dot, dot args is bound to, you could do that. But good call out. Okay. So here we have this, and this would match actually both public and private functions. In this case, we only have public. And what we care to find is we care about, let's see, when we call make, but not when verify transaction is before it. So let's focus on the first part, when we call make. So when we call make, what we're going to do, okay, well, I don't really care about the number of statements that come before the make transaction and after the make transaction. I just care that it's in there somewhere. Generally, when you have something that's like, I just care that it's in there somewhere, you're looking at a dot, 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 something, dot, dot, dot case. That's usually what it is. So if we wrote this, we do dot, 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 make transaction, dot, dot, let's say $T for now, some one argument, and then dot, dot, dot. Now, if we do this, and note that we're not done yet, we're going to go and flag every single function that has a make transaction. So notably, everything except for this guy, right? Okay, that gets us one part of the way. What was the last thing that we said we wanted to do? We wanted to
verify.
remove instances. I see it gets again twisted up. Remove instances where verify transaction is called before make transaction.
Because those are
good. Because those are good. The good cases where verify is before, but only when it's before, right?
But we're going to need some more dot, dot, dots.
We're going to need more dot, dot, dots. So what I'm going to do is I'm going to change this to an all pattern. If I go and I put all, now this one has moved to be a child of this all. I'm going to go add a new one, and I'm going to set it to a not. I'm setting it to a not because we said we didn't want to find this. I want to remove cases where we have, I'm going to copy paste, ret fun, but we call verify transaction before. So if I do this.
And with the same variable, because we don't want to call verify transaction, but send it something else.
Exactly. And I wonder if
Dude,
actually
I've seen it all.
Yeah, and there might be. Oh, here, there's a test case actually example of this. So, for instance, we have this verify wrong transaction where we make a new other transaction, we verify the other, and then we make on the T. Oof, oof. They tried to get around our Semgrep rule. They tried to pwn us. Nope, nope. Actually, because of what Tanya just said, we were using the same $T. Semgrep does something called unification, where basically it checks the two things that are bound to the $T in both cases. Basically, it just enforces that whenever you bind $T, it has to be bound to the same thing, the same variable, the same text. So when I have this $T here, it has to be bound. We bind it once, and then we bind it again. And if they don't bind to the same thing, we kill the match. So this is kind of a twisty thing where we have a double negation going on. This pattern not doesn't match. And because this doesn't match, we don't remove it. So we keep it. You can kind of get yourself twisted here. But the idea here is basically that we don't remove it. That's pretty much all you need to think about in terms of why we keep it there. We don't remove it, so it is still a finding. And that's why we find this one. But let's check the other ones here. So, for instance, this one here is okay. We don't have a rule ID. And it's okay because we call the verify, and then we call the make. That's a good one. So no finding. This one here, we call
May I
make.
interrupt for a second? I think
Yeah, go
one
for
thing
it.
that's really important to remember is if in your brain you're like, no one would ever do that, you need to stop yourself and assume someone might do the thing. Like I've seen so many stupid coding things. Like I've seen developers make a store procedure where all the store procedure does, it takes one argument and then it just executes that concatenated full of injection argument. And like, they're like, I used the store procedure. I'm like, you darn well know that is not
Yeah.
what, you know what I mean? And sometimes it's malice, but 99% of the time, what's actually happening is they just didn't know or didn't understand, right? And so, like, you need to not. So if you're like, no one would ever do that, be like, someone might do that. Like, no matter
Yeah.
how weird it is, you need to make sure you account for it in your rule. So I like that you're doing that, Brandon. Sorry to
Yeah.
interrupt, but
No,
that's
absolutely. That's a really good insight. And 110%, like being a static analysis or program analysis engineer, I looked at so much code that I just like, I don't even know, but like someone wrote it and they do everything under the sun. Every coding pattern, every mistake possible has existed and will exist. So we really have to make sure that we're covering all of our bases because, that one case that you didn't think to catch will come, yeah, and it will go into production code and then it'll get you. And then, so
cool.
we gotta really be careful about these things. So yeah, absolutely, great call out.
Thank you.
And then finally to look at this one, well not finally, but this one we call make before verify. So that's bad, so we catch it. This one no transaction happens because we don't make. This one also we make before we verify. This one we make and we don't have a verify. And this is a good one. We verify and then we make. So I think every example here works in exactly the way that we kind of wanted it to. So yeah, does that make sense to everyone? Is everyone cool with this?
It looks really good to me. Let's see. I see the typing dot dot dot. So let's
Yeah.
see. I feel like the typing, this person is typing dot dot dot, sort of like I spend a lot of time where I'm just staring, waiting for my friend to respond. And then I'm like, what am I doing? Like, cause
Yeah.
sometimes they just never send because I guess
Right.
they changed their mind or whatever. And I'm like,
Yeah, so Juan, that's a pretty good call out. So a doubt about the rules assertion, the okay comments are just for remarking, but not really an assertion, right? True. So one reason for that is I didn't rename this rule. So these test assertions aren't running because these rule IDs have to be the same rule ID as this. And indeed, this okay here, these should actually be up here and they should have the rule ID in them. So really, if we wanted to do this okay, we'd go lowercase okay, and we'd say find unverified transactions. But those ones were more of real comments, whereas this should be an actual assertion here. One last one to round it off. And then here we should be able to actually, all green, all passing. So yeah, this particular example was kind of formatted in a way where we didn't have all of the test assertions that we could have.
what is an assertion? Why do we need those?
Yeah, so these are just a thing in the playground. I kind of mentioned briefly, but these guys, these comments are just a thing in the Sem playground, so that when you're linking a rule to someone, it's very clear what you wanted to match and what you didn't want to match. So this rule ID, it means that on the next line we want to have a match. We need to have a match, or else it's going to yell at us. So for instance, if we made this good, if we did verify transaction on T, if we made this good and therefore not a match, we would have a bad red square here, because what's going to happen is we didn't pass the test because the line must match. So when sending someone a rule, we usually have these test assertions so that we know what was intended by the rule writer. And then finally the flip side is okay, which says that there must not be a match on the next line. Another question, but those okay lines would have to mention all the rules that won't match the following line. Usually in the playground, there's only a single rule of interest. Actually, there must be only a single rule of interest. So yeah, I would have to mention all the rules, but usually that would only be one rule. In the playground, it would only ever be one rule. So it would have to mention the one rule that you wouldn't want to match the following line, if that makes sense.
And it's only for the playground. You don't have to put that all throughout your code. That would be so annoying.
Exactly. Unless you're developing in the Semgrep rules registry and contributing rules, these don't have to exist at all. Yeah, if you want to, so here's the subtle thing. There's a rule, if you download Semgrep from the CLI and you have Semgrep, you can do something called Semgrep test. It will go and look for every foo.yaml with the corresponding foo.py, foo.java, whatever, and then that foo.py or foo.java will look very much like this. It will have test assertions, and it will say okay and rule ID, but it must have semgrep -- test, and it must say the rule that it wants to do the thing on. But that rule will be the same rule ID as the one that is linked in the .yaml. So if I was in foo.yaml and my rule was called foo rule, in the foo.py, I would have //OK or hashtag OK colon foo rule and hashtag rule ID colon foo rule. Sorry, I'm kind of just saying this out loud, and I don't have I haven't written this down for you, but hopefully that makes sense. But indeed, like across different files, you would have different rules that you're writing these assertions for, because the test files are always paired to the test to the rule in your repo. But this is, for other people, this is only relevant if indeed you want to have a repo where you have your own rules and you have tests paired by naming. Yeah. So let's take this as an example. Suppose that this was foo.yaml. So let me write a comment. So this is in foo.yaml, and this test is in foo.py. What we do is we would say our ID here is foo rule, and we would write hashtag rule ID foo rule. And then here we would repeat it anywhere that I expect to match, which is all of these places. So here, here, and here. And then where I don't expect to match, where there must not be a match, I would say, okay, foo rule. And if I ran this, if I don't run this via Semgrep playground, this would be in my repo. I would run semgrep -- test. It would go and find these paired foo.yaml and foo.pys. It would run this on that, and then it would check that this rule ID matches this rule ID. And then it would verify, indeed, you must have a match here, you must have a match here, you cannot have a match here. So it would be paired by the naming of the rule ID, mentioned in both the test assertion in the first party code. Oh my goodness, sorry, I've been sharing the wrong window. Because I shared a specific window, so I didn't find the right one. Sorry.
There we go.
Here, this one. So this file on the right is foo.py. This file on the left is foo.yaml. And the rule IDs would have to match between the left-hand side, this thing here, foo rule, and the test assertions, which mention the same foo rule. Rule ID matches not the test file name, the rule ID mentioned in the test file name. So you see how the test file name is foo, but the rule ID is foo-rule. So I could also call this, let me make this a bit more clear. Let me call this like ABCD. In which case, anywhere that I have foo rule, this will be ABCD. So it's actually not dependent on the test file's name.
Oh yeah, because
And
you
then
made
this
it
would just work.
matching. It was ambiguous. I
Yeah,
see.
yeah. It was a little ambiguous. I should have made it a little bit more clear. But in order to do this, you just want the rule ID in the test assertion, in this case ABCD, to match the rule ID of the originating the tested rule, which is in this case is also ABCD. So it works. Yeah. And remember that this would be taking place like in some repo that you would run semgrep --test from. And it would test out the rules. It will test out the paired rules on the paired files, I think, is what it does. So foo.yaml will be tested on foo.py. So if you had like a bar.yaml, the bar.yaml wouldn't know about foo.py. But yeah. Cool. Okay. If that makes sense.
So how do you get it to test all of the files you want it to test? I think that
semgrep
makes
test, yeah, semgrep test will go into the current repo, the directory that you're in, and find every containing pair of .yaml and .whatever files. So it will just go and do all of those pairs, but it will pair them up by the fact that these were named the same, foo here and foo here. Because the YAML and the test file and the test rule are both named foo, they only see each other.
Will it do everything underneath in the directory structure as well?
Yeah, nested recursively.
Perfect.
Yep, for sure. If a code line matches multiple rules, you do this. I think you comma separate is what you do. I can't demonstrate it in the playground because the playground necessitates that you must have only one rule, but I believe it is comma separated one. Yeah, good call out, though. Good call out. Yep. Cool. Good. Yeah, we're getting into the weeds. This is good. These are why I'm here. So these are questions I can answer. So, great stuff. Cool. Okay, good questions. Okay, so I wonder if there's another example we should want to do right now. Let me see. I have one on. No, not that one. I'm kind of just like checking these things. Do not pass parameters. Yeah, I kind of have to check through my slides because I only have them linked to somewhere else. So we've already looked at a few things, right? We've looked at pattern, any, all, not. One thing to note is there's also pattern inside. So let me show you a pattern inside, basic one. This one's the one that's being, no, this one. So if I make a new rule, we go back to structure mode. What I'm going to say is I want to match when two conditions are true. Let's say I'm interested in prints, but only when they occur inside of a function call. So foo, for instance. So for instance, I would only want rule ID to trigger on this one, untitled rule, but I would not want it on this one because I'm only interested in prints that happen inside of function calls. So I want, untitled rule. What I would write is I want to find the pattern, print ... but I don't want to find, I want to find it only when it's inside of def $func ... colon ... which should look like how you would want to match any function call in Python. So if I run this, surprise, surprise, what's going to happen is we only match this print right here inside of a function, not the one that's outside of the function. And that's what pattern inside is good for. Yeah. So that's another good one to have in your toolbox. But otherwise, that gets us through pretty much all of the basic pattern operators because we also talked about regex briefly, which is a bit more like advanced usage because the whole point of semgrep is we kind of want to get away from, regrets. Right? We want to get away from having regex all the time, which is not super fun, right? So, cool.
For everyone at home, Semgrep has a free academy called Semgrep Academy, available at academy.semgrep.dev. And we have 2 courses on how to write rules, and every single thing in the academy is free. But so if you want to do the Secure Guardrails course or the rule writing level 1, which is super introductory, which you did most of already, you can just go take those courses and continue to learn past these live sessions if you want. And then there's so much more in there. But anyway, I just wanted to mention that for the people at home because I realized I was chatting in the chat with everyone and telling them, and then I'm like, it'd be cool if I told everyone.
Oh yeah, for sure. But yeah, definitely take a look at the Academy if that's something that you're interested in, because there's all sorts of great resources for completely free. So
Yeah.
you should feel so empowered to take advantage of that free learning, because
There might
that's
be a course by Brandon in there.
there might be a course by me if you're interested in functional programming. I can talk about that. That's my jam right there. Cool. Okay. Let's go look at this one. I think I want to do the sec fetch metadata one.
Did you switch
So
windows?
I did not. Thank you so much. And there's actually even an indicator on my browser that tells me which one is currently being highlighted, and I just like totally like missed it. Cool. So, okay, this is going to be a little bit to explain, but basically we are looking at a Rust web application, like a Rust app. And I have a few roots here, and I'm interested in a few of them. I'm interested in hashtag gets. So any root that is not the index function should check fetch metadata. So basically, I'm saying if you are a root and you are index, you are fine. If you are not index, you have to check secfetch metadata, which means you have to have an argument of type secfetch metadata. And if you do have that argument, you are good. If you don't have the argument, you're bad. So for instance, this subtract root is not the index, and it doesn't have a secfetch metadata argument, so it is bad. This one is not the index, and it has a secfetch metadata, so it is good, so we don't want to find it. And this one is not the index, and it has a secfetch metadata, so it is good, and we don't want to find it. So that is basically the idea here. I want to make sure that's clear. So let's start out by writing a pattern for just matching, let's say, any Rust function. Let's start off with any Rust function. Does anyone have a guess for how I would write a pattern to match a Rust function in general?
Would it be kind of the same as the other one? Or
yeah, it would be kind of be the same in the sense of it kind of should look like a Rust function. And if you haven't written a Rust function, that's okay, because there's Rust code on the right here. So it'll look similar in the sense that we're gonna kind of just write what you would normally write in a function call in Rust. So we're gonna give it a little bit. I think that one might have an answer for us, but it'll kind of be, I suspect it'll kind of be what you expect. I suspect, yeah. Yep, yeah. So let's try that out. So seems like it would be fn $func left paren ... and then I think we should need to have. Oh wait, holy moly, that's so interesting. Inside of the chat of this live storm, or did you just copy paste it like that? Yeah, it joins the ligatures of the So ligatures, like when you have like a right like a minus, and you have a right angle bracket. You know how it's like two characters here, but a ligature means that it would like join them together. When Juan wrote his answer, he had them joined together like that. But I think it's actually two characters. So now I have to try it.
It's two characters in the code.
Yeah, it joins them together. That's so cool. Okay, there's ligatures enabled in the in the chat. Holy moly! Sorry, I just got nerd side. That's just a really interesting decision by the application that we're using to host this live stream. This is not related to Semgrep at all. This is completely like just me seeing it and being like, there are ligatures on. Anyways, we need to have this this return type because that's what Rust wants you to have. And one is correct that we would want $ret, and then we would do curly braces, ... So let's match any function. Go ahead and we run it. No, I think it's just like Livestorm just like does that whenever it sees a. Yeah, it's interesting, right? You can tell this is a security mindset, trying to reverse engineer the thing from seeing it. Okay, so now we found every function successfully. Now let's make things a little bit more concrete. What's the thing I said I didn't want to find? I wanted to not find it when it's the what function, Tanya? When it's
index.
When it's the index function. And what does that mean? What is the index function?
Oh, I have no idea what the index function is in Rust.
I don't really either, but basically it means that, well, it's a root, I think, that has slash, I think is what it is my understanding. So if I wanted to do this, what I would do is I would just say, don't find it when it has an annotation that says this one, get, where it's slash. So in fact, let me not even worry about it. Let me not even have to bother to write it out. Let me copy paste it.
Yeah.
So if I run it again,
we need
let's
to
hope
change
that we
the
don't.
pattern to not.
You're right. You're one step ahead of me. Yeah, you're right. I missed that. I forgot to change it to not. So let's change it to not. So we don't want to find this. Oh, sorry. I have to get it. Let me not want to find this. Boom. No finding. So that's proper. However, we're now not getting this finding, and we're not getting this finding, I think, because this one has this. Okay, so let's try this out. So if I wanted to do this, what I should want to do is I want to subtract out the secfetch metadatas right here. Oh, another thing is also, oh, I see what's happening here. The test assertions have to be on the line above. That's something that we missed while creating this. Because the test assertion has to be the line before the match starts, always. So if we find this, what we're going to find is that we don't find this, but we do still find this, which is good, but we do still find these two, which is bad. So in order to get rid of a secfetch metadata function call, it sounds like we should want a not, right? We should want to not it out. So I'm going to add another not. I want to not be the index function, and also I want to not be, let me write this out. I'm going to copy paste this. And all I want to make sure is that there's an arg that is of type secfetch metadata. And I'm going to again do this thing that I showed you earlier, where we do ... comma, something, comma, ... Because we don't care where it appears, we just care that it's in there. So this is a very common pattern we can see. Cool. So now if I run this rule, sometimes this happens randomly. I think it's kind of unfortunate. It sometimes should resolve itself shortly, but sometimes we get this happening. Let me see if I can try it with turbo, maybe.
It's the demo gods.
It's the demo gods. So with turbo mode, it's working, so don't worry about it. Okay, so turbo mode basically makes it. This is another cool thing about the Semgrep Playground. This will make it run on key press. So on key press, it'll rerun Semgrep because Semgrep is that fast that you can run it on key press and it's pretty responsive.
Can you highlight how to switch from turbo to pro mode just for anyone that missed it so quickly?
Yeah, so I was in pro mode, which requires you to make a network connection, and we're having an unknown API error, so I was like, okay, whatever. Turbo mode, you go to up here and you click on turbo right here, and it'll make it run on each key press, which is kind of nice. Cool. So now if we look at this, we have 3 matches. We don't match this one that was okay because it's the index function. We do match this one, which is not the index function and doesn't have secfetch metadata. That's bad. We don't match this one, which does have secfetch metadata. And we don't match this one, which does have secfetch metadata. So we did it correctly. We also matched down here because we didn't, well, we probably should have specified that this has to have a get. So actually, let me just do, for completeness, there's no test assertions down there, so it doesn't actually matter. But let me just enforce that indeed. I did this assertion here, which means that any function that we find has to have an annotation that's get, and the get can have any arguments at all. And this makes sure that we only match these guys up here, as opposed to these ones down here. Just because we want to make sure that we don't have any false positives. Cool. Okay. That is our Rust web app example. And this is a real example that you could run into. So it's kind of cool that you can kind of get by here just with these tools. There's another thing I wanted to show off, which is like, let's suppose that you wanted to match. Oh, wait. Actually, I remember why the OKs were on the next line. So sometimes you kind of care about where your match appears. Let's suppose you want to match something. It's nice when your match is like, let's say, on the name of the function that is like affected sometimes. So if we wanted to make it so that our match, instead of being like this whole thing here, this whole function call, we wanted to make it just the name of the function. I want to show you something called a focus meta variable. A focus meta variable is where I'd go to this constraint guy up here. So this is add constraint to pattern, this little button. And it says where. And I do where focus. Let's not worry about these two for now. But I would type in the name of a meta variable. So let me type in $bunk. When I do that, my match changes, okay? It makes it so that instead of matching on the whole function from here, I focus in on this $func. So whatever binds to $func, I go and I specify to it. If you remember the example earlier from the AST nodes where like we had like 1 and A and B that were like sub nodes of the bigger one, all we're doing is we're saying, I want the smaller node of $func. I want that guy in particular. So here we get subtract instead of the whole thing. And then there are no other matches, but were there to be other matches, we would match on only the function name. There are reasons for why you'd want to do this.
I was just going to say, because you want to switch it to a different function name?
Maybe because you want to use the range to like extract something, like if you're using Semgrep for like you want to post-process the data, or maybe because you're doing a taint mode rule, and taint mode rules are a bit more particular about ranges and stuff like that. Yeah, and we might get to taint mode today. I'll show off one. I won't go too in depth because those are a bit more advanced, but we'll definitely get to taint mode in a bit. But yeah, so focus meta variable can be very useful here. Okay, so that's a good example right there. Let's see. I wanted to do one that uses another meta variable feature. So let me show you this example. If everyone's cool with this one. Well, I already went away, but okay. So right now, what we have is we have this like Go program. We context switched. Now we're talking about Go. All right. So when we have Go, we're going to try to generate a random private key using this RSA library, and we get to put this like number in, and we want to make sure that like this number that we use is less than 2048. I actually don't really know why we want it to be less than 2048. We want to make sure it's of a certain strength, I think is the reason. But basically we want it to be sorry. Other way around. We want that's how they get you. We want it to be greater than 2048. Bigger is more strong, but if it's less, we want to find it. That's how they get you. Okay, so in order to do this might seem a bit hard to do because we want to match 2048 and 2049 and 2050 and 2051. Tanya, when does it end?
I mean, with quantum computing, I'm really not sure when it's going to end.
Never, possibly. Never.
Yeah.
We might never end. You're right. So what we want to do is we want to actually use a stronger feature that lets us use numeric comparison. So in order to find all instances of this generate key, I'm just going to write rsa.generate generate capital. Okay, so let's start off. So again, let's do this thing where we kind of do it iteratively. Let's start off simple. We run it, and we're going to find both of them. Cool. Whatever. Oh, it's working now, yeah. We want to find both of them, but we are still finding this guy. We don't want to find it because it's of sufficient strength. It's greater than or equal to 2048. So what I'm going to do is I'm going to use something called a meta variable comparison, where I can bind a meta variable and later on say a certain condition about it in Python really, and say something about like the magnitude of the text that it's captured, the number or whatever. So to do that, first let me capture it. So the last argument, or the second argument, to a generate key is the strength. So let me do $strength right here. So, and another cool thing you can do here is if you put the meta variable, any meta variable, into the message of the rule, we didn't talk too much about this, when you get the match, it will actually interpolate it and put the text that the meta variable matched into the rule. So let me show you right here. So for instance, we said RSA less than 2048, $strength. In here, $strength is 1024 because on line 12, that's what it matched. And here, it's 2048 because on line 19, it matched 2048. This is a nice way to kind of debug your rules. If you're not sure what a meta variable is matching, you can put it in the message of the rule and literally look at what it's matched. So now what we want to do is we want to say something about $strength. So we just looked at focus, which restricts a finding to a meta variable's range. Our next thing is that we want to filter a finding based on if a Python expression is true. This doesn't work for all Python, only for like a limited subset. So there's no security concerns. But basically what we can do is we can say $strength. I can spell. All we want to say very, very simply is that it's greater than or equal to 2048. Now, if I run it, I'm going to not find, wait, hold on. Other way around. It's bad if it's less than 2048. You can kind of just do this iteratively, and if it doesn't match the thing you expected it to find, you can tune it. That's why these rule IDs are really helpful, because it helps you check your work, grade yourself. So when it's less than 2048, that's bad, so we find it. So in this case, we're able to correctly find RSA generate key on 1024, but not on 2048, because 2048 is sufficiently strong.
Cool. Can you switch the 1024 to 512 and just make sure it still finds it?
Yeah, for sure. So let's do 512 and make sure that it still works. Any number less than 2048 should be able to be found. So for here, we are able to still find generate key when it's on 512 and when it's on 256 and everything dividing by 2 thereof, and also every number in between them. So yeah, that'll get us there. Yep, good call out. Cool. Any questions on this?
I feel like a question's coming in.
Yeah. What if you put some garbage that can't be a number? It's just going to realize that it's not a number, and then it's going to not find the finding because it can't do the comparison. Or wait. Yeah, sorry, this is what I expected. Sorry, I should have replaced this one. So instead of 2048, it's some garbage that's not a number, so we don't care about it. This is not a concern, so we don't match it. Yeah. But it's not gonna do something weird like cast the string to a number and then check if the number is greater than 2048, because that would be really silly, and that is what some programming languages do when you cast, and I don't want that. I don't want that to implicitly happen. That would make a semrep rule like have a gotcha, and I don't like that. So indeed, only if it matches. If the target language is case insensitive, so is semrep matching. So if you said that your function name should be foo, we actually did work on this. We had work on this, so it depends on the language. I know in Ruby, I think there's something about case insensitivity for something, maybe function names. And I remember that there was some work done by one of our engineers, Amarin, where he did some work to make sure that it would match in either case. So if we had a language like SQL, I don't know that the matching would be case insensitive because we would have to kind of like flag that and implement that, but it definitely should be. So that's the intention. It definitely in some languages that would be the case. But yeah, ideally we should follow the semantics of the language that you're scanning in, even though we kind of use like a more unified approach that is reusable for all of these languages. But good question. I haven't looked at a whole lot of SQL semrep rules, but I have been wanting to write a few because I feel like there are like some cool things you can do with semrep to kind of disallow some like unperformant SQL anti-patterns. But yeah, that's a good question. I'm not sure if it'll work for that particular example, but it should. Cool. Okay. Yeah. Any else before we move into, I think taint mode is what we're going to move into. Yeah, there aren't, which is nice. That's the cool thing about semrep is that like most languages, most programming languages, if you like squint your eyes, they all kind of just like look the same. Like they all have functions. Those functions call each other by name. They have arguments. There are classes usually that have inheritance. So that means that like even though like Python class inheritance doesn't work exactly the same as Java class inheritance, 95% of it probably does. And just by analyzing under those 95% of assumptions, we can get 95% of the use cases. And when we're optimizing for like getting all of them like use cases that matter to you and not finding all of the ones that are bad, like that 95% gets us a long way. So that's something I feel really, really lucky about and really passionate about for semrep, is that like we do the work that's necessary to get all of the things that are very, very the most important. Yeah. Okay. Are there any other questions about anything in general before we move on to something different? I wanted to move on to taint mode because I feel like that's a good one to kind of end off on, because that's kind of a cooler feature of semrep. Okay, I think we're good then. Cool. Let's see. I'm just going to go ahead and start it off while Tanya comes back, because there's a bit of an explanation we got to get into there. So let me. Oh, Tanya's back. Hello. We were going to go talk about taint mode.
Taint mode sounds good.
Cool. Okay. Let me share. Not that. Yeah. Okay. Cool. Okay. So we're going to be using these slides because I like them and I think that they are pretty. But so most problems in security are not as simple as what we just looked at, which is called a search mode rule. A lot of problems, sorry, in security are just as simple as you have sensitive data and it goes to bad place. And I'm so serious, like that is so many of the problems are just bad, like sensitive data goes to bad place. And those are not always as easy as a single search mode, right? Because that's actually a query that has two parameters. One, the place where the data comes from, like an API call or a file read or a database load, whatever. And then the bad place, which could be many layers later. Like could be like 10 files away, 5 function call stacks away, whatever. So we have to use what's called a taint mode rule, which is a little bit different. For that end, we use something called taint analysis, which is something called data flow. It's a kind of data flow analysis, which tracks some kind of data called a source. That is our sensitive data. And it checks whether or not it can go to some sensitive, bad place we don't want that data to go, called the sink. And we say that the data that comes from the source is tainted. So we're checking if tainted data is going into the sink. So if we wanted to go ahead and look at how this works, let's look at this example in particular. This is Java. I have a data flow example, and I have a main function. And my main function takes in potentially sensitive data from args, from my argv, from my command line arguments, right? That's a potential source of user input. They might put, I don't know, like a password or something in there. And I want to make sure that that does not go into a runtime.exec method, because that could go into like, I don't know, an HTML, a post request that's going to go like upload that password to like my special, database somewhere. Okay, let's not let that happen. So, and in particular, like some examples of common sources might be like URL, parameters, cookies, user input, database loads, and common sinks are stuff like SQL queries and shell commands, which could lead you to like SQL injection, for instance, or some other kinds of stuff. So if I wanted to deal with this case, what would I do? Well, let's trace the flow of taint, assuming that we want to taint the args function. So first, the source is the args argument to main. So that is tainted. And because args is tainted, args index 0 is also tainted, because if args is tainted, args index 0 could possibly be still like a bad thing. Next, we say that because it's assigned to it, CMD is tainted. The newly declared variable CMD is tainted. And then because CMD is tainted, the usage over here of that same variable CMD is tainted, right? Because they're the same thing. And then because that usage of CMD in this function call is tainted, we land inside of the sink, which is the exec method. Note that we're literally checking that we are inside of the text, the range of exec. This is where the range stuff really comes into play. Let me say this. Because the source, or rather, because tainted data represented via blue data landed inside of the red, we ultimately convert this to a yellow semgrep binding. So we would mark a match on this line, but don't forget that the reason why we have a yellow match on this line is because the blue data went into the red. It's as simple as that. Because the blue data went into the red, because the tainted data went into the sink, we end up having a match, a binding. Let's see. And this is exactly how Semgrep works. All it does is it lets you specify, one, your sources using patterns. Two, it lets you specify your sinks via patterns. And then Semgrep does a lot of thinking. It does a lot of like data flow analysis. It does some computation to check if there's any way that the thing that you said could be tainted, the source, could make its way into a sink. And if it does, then it raises you a finding.
Because cross-site scripting, because injection, because all sorts of badness.
Yeah, because all of those things are very, very bad, are very, very bad, are very, very. Oh, fun! Yeah.
There we go.
Bad. My piano turned off. Bad. We don't want to find that, so we got to get rid of that.
Seriously, Brandon, if we got input perfectly validated and then sanitized or escaped or whatever you choose to do, so that every time it was safe before we used it, I think like half the vulnerabilities in the world would disappear. Like
Honestly, yes. Yes. If
yeah.
we
So
properly
taint mode,
sanitize all the things.
it's very important. This is
Yeah.
very important.
And it's funny you use that word sanitize. So tell me more about that. What does that mean exactly?
So first, I always validate input. So is this what I'm expecting? If it's a date field, is it a date? Is it in the range? Is it all these things? If it's a username, there's certain characters that are acceptable to me. But let's say I have to accept a special character. So let's say it's a person's name, and one of the founders at Semgrep's named Luke O'Malley, and so his last name has a single quote in it. That's a dangerous character. And so we would sanitize out that dangerous character, remove it, and then replace it with something else that is fine, that's safe. Or we could escape it by putting a backslash in front of it to say, take the superpowers away from the following character.
True.
So either removing it, replacing it with something like a tilde or something that's safe, or like escaping it so that it's powerless.
Taking away superpowers and while giving security engineers their own. That's how I like to think about it. So that's what we're out here to do. But yeah, absolutely correct. Yep. And that's really topical because of Luke O'Malley, he ran into something about character encoding about his last name recently. So that's pretty funny. Yeah, that's a real example. That's not a joke.
Yeah. Oh yeah, no, he's told me he's had issues where they're like, your last name's not right. He's like, no, that's definitely my last name.
Yeah, I checked, right?
I'm very sure.
Yeah. Right. Yeah. So exactly. So to show off, let me actually go and show you a taint mode rule now. If I wanted to do that, let me share my screen and go back to one of these. I don't know which, but it's fine because I'm just going to reset it anyways. If you go to new rule, you can also go to data flow analysis. And this will give you a data flow analysis rule or a taint mode rule. So basically, I have a couple of roots, and I have a function called get user input. Now, unsurprisingly, get user input does a thing where it gets user input, which could be sensitive. And there are two bad things that could happen, which are that it could either go into this HTML output, which could be scary, or it could go to eval, which is kind of scary also. So if I wanted to run this rule, so this is something that we haven't talked about yet. Let me actually, let's just go with it. If I wanted to run this function, I would get one finding, which is where the get user input puts it into HTML output. But it didn't do that here. The reason that it didn't do that is the thing that Tanya just talked about, sanitization. Sometimes when you write like your custom things, one link to XCCD, nice. Sometimes when you are doing your validation here, once you validated it, you're now sure that this data is safe. It's safe. You can use it. So that's called sanitization. And your sanitization function in your code base might not be named the same as my standardization function. Let's say that you're checking for like alphanumeric characters plus or minus like 1 or 2, and I check for a different 1 or 2. We roll our own functions. So this is where the customization aspect comes in handy, where you can write a Semgrep rule where you have your own sanitization function called sanitize_input, and I have my Semgrep rule where I've sanitize, camel case, capital input, right? But we have different rules for different use cases because our rules are not compatible in each other's code bases. And so the reason why this doesn't work is that sanitize input takes in this data and it sanitizes it so it is no longer tainted. And I have a pretty diagram I can show you here on why that is. So assume that we had our appropriate sources sanitizer definitions. In this case, we're going to say that we have a function called filter file path that functions like a sanitizer. Args is still my source, and runtime.get_runtime.exec is still my sink. So given those, we start with the blue source, which becomes tainted, which taints args of 0, right? But it goes into this green sanitizer, which ends the taint. The taint no longer exists, so this string sanitized path is not tainted. And then that's it. No blue goes into any red, therefore no finding. Simple as that. It wasn't able to link them together. It wasn't able to find a path in which the blue was able to go into the red, that the taint was able to go into the sink. And as simple as that, there is no finding. There is no finding because there's no way for sensitive data to go into the sink given the appropriate sanitizer definitions. Yep.
Oh, in the chat, we got the good job sign.
Yep. Good job. I think so too. Good job, Semgrep.
Oh,
Pat on the back.
Brandon.
We did it. Cool. Yeah. So, and this is very, very powerful. Like, okay. So, like, I want to kind of stress. We talked about these search mode rules, and they're like not too bad. But really, like, they're like kind of very simple. The examples we went over, but the stuff that we looked at with these sanitizers and sources and sinks and stuff are just that repeated over and over again. It's just patterns and things. So it's the same principles repeated over and over again, used in kind of like new use cases, but the same foundations. Juan, I feel like you had a way to finish off that. He says awesome, more like. I feel like there's a punchline coming.
Oh, because I said good job, Brandon, and he's like more like awesome.
Oh, never mind. I can't. I thought it was like a setup. I thought it was like awesome, more like Semgrep. Something like that. I see. All right, thank you. Cool. All right, we're having fun. But I think that also this is what's super cool about education, and in particular like the Semrup Academy on like Semrup Rules is like this stuff is really foundational. You kind of just like we teach you the foundations and then we repeat it over and over in more use cases until you kind of realize that the scope of things is the same thing. It's the same thing. It's all patterns. It's all ranges. It's all pattern not and pattern and any and all over and over again compose into your particular use cases. So as someone who's avid about education, that makes me really excited about Semrup's education. Yeah. And I know you are too, Tanya. I know you're excited about that too. Cool.
Yeah.
Let's look at an example because I think that it's good to look at a real example of a thingy, where thingy is defined to be a taint mode rule. Let's see. Okay, so I want to match calls to runtime.exec. So here's what we're doing. We have an HTTP servlet request, and I'm calling getParam on it. So I'm getting a query parameter for my HTTP request. And I'm calling runtime.getRuntime.exec. And what I want to do is I want to check whether or not any of those things are going into an exec, whether a getParam is possibly going into an exec, because as we kind of identified earlier, that's probably kind of a bad thing, right? So what we're going to do is this. What is my source here? Well, my source can be a lot of things. I could be talking particularly about the get param, or I can just kind of say that like the HTTP request, like that, the servlet request variable itself, that is itself kind of dangerous. So what I'm going to do is I'm going to say that my sink, my source, is I'm going to use what's called a typed meta variable. I didn't teach this to you yet, but we're going to go over this right now. A typed meta variable is basically saying anything of a certain type, match that. So in this case, anything of type HTTP servlet request is potentially a bad guy. That is like dangerous. So let me type HTTP servlet request space $rec. So the reason why this is a typed meta variable is in Java, when you have arguments to a function, you do the type space the name of the identifier. So in this case, I surround it in parens. I put the type that I'm interested in constraining the meta variable to, and then I put the meta variable's name. This is just the syntax of how we do it in Semrup. It's that way because we kind of chose it to be that way, but it should kind of line up with how the language does it. So I can't show you what this matches yet because taint mode rules, right, do like two matches. They match the source and the sink. We're gonna have to define our sink now. Our sink, we want to match .exec, but we want to match .exec only on an object of type runtime, because runtime.exec, right, that the class method of exec on runtime objects, that is the bad guy. So in order to constrain ourselves to that particular case, what we're going to have to do is we might use another typed meta variable. So in particular, what we're going to do is we're going to say my sink, when I have runtime, I use obj. When I have an object of type runtime, I'm going to actually do a dot access on it. I'm going to say if you call dot exec on that method, that is a sink. Okay. Trying to think of if there's a good way for me to show you what these match right now. Let's just go ahead and do the full taint rule. So if I run this, so here we have, let's try to visualize with me like where the taint is going. First, we find something of type HTTP servlet request, which is named rec in this case, and we taint it. Now, because rec is tainted, rec.getParam is tainted because we're accessing a method on that guy. That could be tainted for sure on that object's data. So this is tainted. Because we assign it to CMD, CMD is tainted. Because we use CMD again, CMD here is tainted, right? So this is now tainted. And because we said that RT is of type runtime, this is a sync. This sync pattern here, runtime obj.exec, this matches this whole thing because RT is said to be of type runtime. And then clearly, do we have a case of colors mixing? Have we made purple? Tanya, this is your favorite color. Have we made purple? Red? Has the red gone into the blue? Or the blue gone into the red?
I don't really know.
Oh, I was thinking of the fact that when you mix blue and red, you make purple.
Yes.
In this case,
yes.
Actually, I don't mean to say that because purple is supposed to be a happy thing, okay? But in this case, purple is actually bad, unfortunately. But yes, we made purple. We made purple because the blue went into the red. So this is a finding. This is a finding, right? But why isn't this one a finding? Let's see. Well, let's check out the taint. So let's go through it a little bit faster. Because it's HTTP servlet request, rec is tainted, so rec.getParam is tainted, so CMD is tainted, so CMD is tainted. Okay, so the blue goes there properly. But when we call rt.exec, what's that we said that RT had to be, Tanya? What does RT have to be? RT has to be based on this pattern of certain type, of type runtime. So because it has to be of the runtime type, is other the same as runtime? Is the other type the same as runtime? Is RT of type other the same as RT of type runtime? I don't think it is. I have a sneaking suspicion, Tanya, that it is not. So that means that, all to say, this is not a sync. The blue goes there, the red does not. I can't show you this on the fly with pictures, but that means, and that's a good thing too, because it means no finding. This is okay. That's okay. It's just an exec method of something else. No false positive. Yes. False positive being, bad. So
that would
no false positives.
Terrible coding, though, to give it the same name when it's a different type and it does a different thing.
Oh yeah, that'd be straight. That'd be quite weird. Yeah. In this case, like maybe also this exec is also sensitive, in which case maybe we want to flag it, but I'm assuming that it's not in this case. We don't actually know. It depends entirely. But that's the customization aspect also. Like you'll find out whether or not it is. And our security researchers who spend like all their days like writing rules, researching libraries to figure out what is vulnerable, what is not. That's kind of what they do, is they customize these rules to make sure that they work within XYZ framework for ABC languages. Yeah. But indeed, so we don't have this finding. Here we have a similar thing here where because so this case rt.exec is of type runtime, so this is red, it's a sync, but CMD comes directly from the argument, so it doesn't come from an HTTP servlet request. This CMD might not be user controlled. Maybe it's a constant string. Maybe all I did later on, somewhere like public, like foo, all I did is I called OK2 on, rec and like that, I don't know, curl. Maybe that's all I did. In which case, it's not user controlled. It's not dangerous. So let's not worry about it, right? Okay. And then finally, this last one. So let's go through the taint trace again. So rec is tainted because it's an HTTP servlet request. So rec.getSafeParam is tainted. So CMD is tainted. So in this case, we have a sanitize right here. In this case, actually, oops, sorry, we should have, wait. No, in Java, you can do this. You can say sanitize. What we probably should have done, I think, is we probably should have, so I kind of skipped over this because I wanted to get to the specific sources and sinks, but we can also add a sanitizer here, and then say sanitize : or left paren ... is sanitized. Yeah, is cool. In which case now, when we go in here, this blue is inside of this call, which is sanitized. So it's green. So we don't have taint on this. Yeah. So we get the red here, but we get no blue because we sanitize it. Yeah. Great observation. And that is pretty much how taint traces work. That is data flow analysis. It's just like applied versions of that is pretty much all that's happening here. And you extrapolate that, you go to more examples of functions, you go to longer functions, more things, and that is pretty much all that happens. One thing I wanted to also kind of mention is we looked at examples that are what's called intra-procedural. Within intra, a single function taint traces. What we can also have is we can have inter-procedural functions data flow analyses. So to show you this really fast, basically what we can do is let's suppose we had def foo, which takes in Python, that takes in a function a and it puts it into exec of a. Okay, and let's suppose we had an input, which was input here. Actually, let me do two examples. We're gonna do foo, and then down here we're gonna do bar. And I'm interested in when x is equal to input, and then we do exec of x. Sorry for the colors. I gotta reset that. And my sync is gonna be exec, and my input is gonna be input. Okay, and then let's get rid of the sanitizer for this example, and let's make a little bit of room. In this particular case, we should expect a finding on line 6, right? Because I put input and I put it directly into exec, but we haven't called foo yet, so no finding, right? What OSS Semgrep can't do, but what Semgrep Pro Engine can, is something that's cool is that we also can do inter-procedural analysis, where if I said y equals input out here, and I said foo of y, to be able to stitch this together, we'd have to be able to say that this y that's assigned to input, the taint from y goes into the function across functions inter-procedurally. And it actually turns out to be that the Semgrep Pro Engine can find this. And there's a little star here because you wouldn't be able to find this with Semgrep open source, but because it's a bit lighter, it tries to do a bit more fast bit analysis, but Semgrep Pro Engine can. So some things to note about the data flow analysis is that when you want to find like inter-procedural, cross-file, cross-function findings, you're not going to be able to do that with Semgrep open source unless you kind of like do a little bit more special case things. But that support kind of does exist within Semgrep more generally.
Nice.
But yeah, any other last questions while we're wrapping up, I think? Okay, no need to describe how, just if, yes. There's one rule I will have to implement to check that no more than one input argument to a function is modified therein. So it is bad if more than one argument to a function is modified therein. Okay, let's do this in like, I'm gonna go, when I think of going to, modifying, I'm thinking of like a mutable language. I'm thinking of like C. So I'm gonna go ahead. I'm gonna just do this in C. Okay, it doesn't need to be C, but I'm just gonna do it because that is just what makes sense to me in my head. So let's suppose we had like int main, or not int main, int foo, taking in like int A, int B, int C. Okay, they can be ints, they can be strings, whatever. And we want to flag it when there is more than one argument that is being modified therein. So like, let's even say that they're like pointers, okay? If they're like pointers, like you could possibly like persist some changes outside of this. What I would say is I'd say something, and in particular, let me spin up some more examples. I don't know why I'm doing this thing. Let's ignore that for now. Yeah. So let's have one example where we say like star A or A. Let's just do the assignment. A equals 1, and let's do A equals 1, B equals 2. And let's say that like this one here, rule ID, simple taint rule, or sorry, this is okay. Okay, simple taint rule, and this one's rule ID, simple taint rule, because it modifies twice. And let's do another one where we modify 3 times. Okay, and this is obviously like a pretty synthetic example, but you could generalize this. So first off, what I'm going to write is I'm going to get my head on straight. I'm going to make sure that we can match the semrep, the functions at all. Okay, so first cut, we match all the functions. Now, let's check to see that it has a certain number of arguments. What I would do is, because we're checking to make sure it has, let's even generalize this. If it has 1 argument, it's okay, right? Because we can't possibly modify more than 1 if it only has 1. So let's say any argument that has more than 2 or more arguments. Var A, yeah, tie 3, $B, sorry. Okay, do you see what I'm doing here where I'm saying this is the same pattern of dot, 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 some stuff, dot, dot, dot. I've said I'm now localizing my finding to any function that has any number of arguments, then 2 arguments that have any name and any type, and then any number of arguments. So 2 or more arguments, basically, is what I'm saying. And now, notice that, this actually would not, let me go back to here. So this would not find this. We would not find this example here. Yeah, so this is okay. Great. All right, let's iterate it on again. Now I want to make sure that those 2 arguments that I've picked, I have modified them somewhere in the file. So what I'm going to do is I'm going to do this dot, dot, dot thing again, where I say one of them, I'm going to say $A is equal to E1, and then again, $B is equal to E2. Now, we're missing a case here. I'm going to demonstrate this in a second. I am knowingly missing something, but this should work, I think, for examples that we have here. Yes, so now we find the one where A equals 1, B equals 2, and A equals 1, B equals 2, and C equals 3. But there's something that I'm missing. And one, actually, I'm really curious on whether or not you can anticipate. I'm matching my test files, but there's a case I'm going to miss with this rule that I think you're interested in. If B is modified before A, rockstar, you got it. Yes, exactly. So what I would actually do is I would do a pattern either, and I would just permute them right here.
I just swap them.
And then I would spin up another one, another rule ID where I do this. A equals. And then if I do this, now we should be able to find all these examples. Worth noting, in this particular example I've chosen, there's still improvements you can make to this rule. I think this has the idea, but here's one complaint, which is like, okay, ints are like local to like the scope of your function. If I reassign the int inside, it's not going to do anything. So maybe you're actually really interested in C, you'd like want to like make it so you only do it like if you do like a $dereference, like you say I dereference the variable and I change what it's pointing to, and I think that this should work. So I believe this should find nothing. Yes, it finds nothing. And if I change these to be dereferences, I believe this should now find them. Yes, it does. And it didn't find these because these are not dereferences. And you could also write another rule if you wanted, where like these would be like, arrow dereferences, so on and so forth, right? So let me just demonstrate that one way. You get into kind of casework here. There's some stuff I can do to make the casework less, but I'm just going to do it all out here because I think that's all we have time for.
Could you go into the advanced mode and then copy and paste that into the chat just so that like
yeah, for sure. Slow down Shakespeare, too many characters. All right, I'm gonna paste spin it. Paste spin, create new paste. Here you go.
Oh, he says it's okay.
Oh really? Okay, cool. Yeah, sounds like you got a handle on it, but yeah, and I have to say, all of this worked exactly as I wanted it to, like the dereferences and the arrows. Sometimes there's some rough edges for languages that we don't support, or I don't think about as much, but we actually have pretty good C and C++ support. Yeah, it's not so bad, right? I think it's just kind of like, it's like kind of your intuition of how you'd want to do it. But yeah, very good use case. This is actually this is a good exercise, this one right here. I like that. Nice. And I try to decide, provided you can rely on finding an assignment, yeah. And it would depend on your particular language, what that would look like. I chose C because I thought that it kind of looks a bit nicer. But yeah, for sure. Very, very good example. Thank you so much for bringing it along. Yeah.
Thank you so much for coming, everyone. This was great. And Brandon, you're great.
Thank you. You're great too. We're great. This is great together. We were all great. This is a great time. But yeah, thank you so much for having me. Really appreciate it.
Oh, my pleasure. Next month, everyone, we're going to have Kurt on, and Kurt's one of the researchers at Semgrep, and we're going to look at Query Console, which is like a newer feature so that you can just write a rule and then do it across your entire code base. And thank you very much for showing me this cool new structure mode, Brandon. I really like it.
Yeah, absolutely. Super, super happy to. And I think more people ideally could use it and get some use out of it. But yeah, thanks so much for being here, everyone. Let me just, end us off.
I want my guests to play musical instruments more often. This is great. Awesome.
I feel like it's fun to just have like a little like, look, yeah. I should do this more often. Yep. But yeah, thank you so much for coming, everyone. Thank you so much, Tanya, for having me.
Thank you, everyone. The recording will be available online soon, and we will link to it, of course, in our newsletter, and we'll see you next month. Thank you.
Cool. All right. See y'all. Thanks for having me.